Hello calculus students, let's have a review session. This problem set here is very similar to the practice exam problem set that I posted in Canvas. As a matter of fact, that practice exam problem set is the one that I used previous semester, and this notebook is actually written for the practice, the preparation for that exam, the very exam, so there's no wonder they are very similar and comparable. I didn't want to write a new notebook, so let's just go with this one. First problem, limits and limit rules. This one is a 0 over 0 type limit. If you plug in x equals 2 and run your computation, then you're going to get 0 over 0. So what do? Method number 1 is to factor the numerator and denominator and cancel out the 0 factor. And method number 2 is L'Hopital's rule. This is a textbook's method. Factor out the numerator. Let's see, the numerator is quatic and there's no GCF, so factor it with respect to x squared. Let me expand the font a little bit. And the denominator is cubic and it has GCF of x, so factor that one out, and what's left is quadratic. And then factor further, and please note now that x minus 2 is common. So cross those out, then we have this. Now we are ready. Plug in x equals to 2 and run your computation. That's what you get. Another way is L'Hopital's rule, and this method is not textbook's method, but it works out. Just take the derivative of the numerator and the derivative of denominator, and then plug in x equals to 2. If you still have 0 over 0, then you have to take the derivative again until you get something. And in this case, just plug in and you ended up with the same value before. This works out just fine if you have polynomial over polynomial. For the second problem, however, L'Hopital's rule will not work. So this is infinity over infinity type limit, and if you try to take the derivative, you'll see derivative of this radical is gonna be something really messy, and same for this one. So you have to wonder, the purpose of all this limit rule and everything is to make the problem simpler, and if you take the derivative, you're getting something worse. Clearly, that's not the right way, so find something else. How do you do it? This is my suggestion. Basically, take an asymptotic estimation. So asymptotically speaking, lower order terms do not really contribute, so cross all those out. And we have only higher order terms, and second order here, and this 2 is second order because fourth power and then square root, so 4 over 2, the second order. This is second degree, and that 2 is second order. You see fourth power divided by 2 because it's inside the square root. So now everything is second degree here, and then take the like terms together and simplify, you get 4. This is what I recommend to students. Now, how about our textbook's method? A little bit more theoretically sound, but here we go. Divide everything by the highest order term, which is x squared, the second order. Divide everything by x squared, and we have x over x squared, that'll go down to 0. And then inside of the square root, I have to divide by x to the fourth power. Because this is square root, if x squared goes inside, say, cubic root, then you're going to get 2 times 3, 6th power. But it's rather unlikely you're going to see cubic power or something more complicated because square root is hard enough. So divide each by x to the fourth power. These will be gone, and these 2 will go down to 0. And what's left is a bunch of zeros and some numbers. Simplify those numbers, and you get the same answer as before. This is textbook's method, and this one is coming from the limit rule. As a matter of fact, if you apply limit rule here, this goes to 0, this limit goes to 0, that limit goes to 0, and so on. Previously, I used asymptotic estimation. Either way, it works out. Okay, so much for limits and limit rule problems, and let's go to the next step. Graph problems. Okay, here's a graph, and determine the given limit. Let me copy and paste this thing. Okay, now everything is in the same viewing window. All right. Now, how about this? Limit x is going to -1 from minus side. X is going to -1 from plus side. X is going to -1 altogether. No, excuse me. X is going to +1 from minus side. X is going to +1 from plus side. X is going to -infinity. X is going to +infinity. And then the limit values are always y-coordinates. Function values are always y-coordinates, remember. So f of x, eventually you have to find out the y-coordinate. All right. X is going to -1. X is -1 is here, but from which side? From the left or from the right? You see minus sign here, so it's left. So follow the graph to the left, and y-coordinate is going down to -infinity. I hope everybody sees that, going down to -infinity. Follow the graph. Now, how about -1 plus? This is right inside. X equal to -1 is here. Approach the graph from the right. So follow the graph from the right. Y-coordinate is going to, what's the y-coordinate here? 2. Okay, so much for -1. Now +1. X is going to +1 from minus symbol here, so left-hand side. So x equals 1 is here. From the left, follow the graph. Follow the graph, and y-coordinate goes to -1. Now follow the graph from the right this time. It's going to, what? +3. So y-coordinate is going to +3. Okay, 2 more. Limits going to infinity. X is going to -infinity, so I'm going to the left all the way. And then looks like the end behavior is asymptotic. So y-coordinate is getting closer and closer and closer to +2. I see the horizontal asymptote. Now, how about to the right? For x is going to +infinity, this end behavior is not asymptotic, it's going up. So going up forever, we have +infinity. And that'll complete the problem. Let's see, infinity is a little bit complicated. Y-coordinate going to infinity means graph is going down to the pit or going up to the ceiling, like this. X is going to infinity, -infinity, infinity, is going to left or right. And then check for the asymptotes. Y equals to 2 is the horizontal asymptote. That's related to this. And then x equals to -1 is vertical asymptote, and that's related to this. But in any case, just follow the graph. Okay, so much for direct limit. Next, a little bit harder limit. All these are actually the derivatives or slopes. All these are derivatives or slopes. So h is going to 0, so the difference of x coordinate or rise is, did I say rise? Excuse me, run is going to 0. The denominator is run. And the difference of y coordinate, that too is going to 0, so we have 0 over 0 type limit, and we have to figure those out. At which x coordinate value, that's the problem. And when h equals to 0, we are talking about x equals to 2, so right here, x equals to 2, where my mouse is running. So find out the slope of the given graph at this point, x equals to 2. What is it? This is a line segment, so it's easy. Find out the slope of this line segment. What is the rise over run here? Goes 4 steps down as I move 2 steps to the right. 4 steps down, so rise is -4. Actually, simplifies into -2. As a matter of fact, even if I write different kind of problem, not 2, but for example, let's see, say for example 3. No, not 3. 3 is all the way over here, so 2.5. 2.5 is over here. Again, it's lying on the same line segments. It would have been the same. What if I select about 1.5 or say 1.75? 1.75. Still -2. If I select anything, any x-coordinate value between 1 and 3, the slope is the same because we are looking at the same line segment. So the answer would have been just -2 all the way. Okay, that's the easiest case. Let's go to the next one. Slope at 1, but there's a bit of a problem here. Slope at 1, x equals to 1, we have a breaking point here. So which is it? Left-hand side or right-hand side slope? Do you see this 0 plus? That means it's the right-hand side slope we are looking at. At x equals to 1 here, right-hand side slope, this one. What is it? Same like segment that we saw before, so it's -2. Next, let's go to problem C. Now x is 3. Do you see 3 here? And h is going to 0 minus. So left-hand side limit. X equals to 3 here, and left-hand side. Left-hand side slope. Same line segment again. Same slope. Okay, finally, we have something different here. At x equals to 3, h is going to 0 plus. So it's a right-hand side slope. To the right. From here to the right. It's curved, so I have to consider a tangent line this time. Here to the left, the graph was itself a line segment, so you just have to look at the graph. But here, no. Graph is curved, so just looking at the graph is insufficient. You have to get a line, a tangent line, and I hope everybody can clearly see that to the right, tangent is horizontal. To the right, I mean, over here, horizontal. So the slope of horizontal line is 0. That's how you can answer it. Let's see, do I have additional picture here? No. Okay, alright, so my 4 graph problems as well. Looks like I have several more problems, but let's stop here and let's continue in a separate video.